So, ladies and gentlemen, on this video, I'm going to explain the even ones. Number 2, it is in vertex form. So the question is, what is the vertex? The vertex is the coordinate. Think opposite on H and take K for what it is. So opposite on H, that's a positive 2. Take K for what it is, a negative 5. So go to positive 2, 1, 2, negative 5, 1, 2, 3, 4, 5. Put a dot right there. The very next thing to do once you have your vertex on any parabola is to draw your axis of symmetry equation. The axis of symmetry equation, and that is the equation x equals the x value of your vertex, which we know is 2. Okay, so the axis of symmetry equation is right here. That's your answer. X equals 2. That'll provide that vertical line, which provides a reflection on both sides of it, right, when you draw your parabola. So we need more points. One option is to go to an input-output table and plug in whatever number you want right here, do the math, square it, do the math. But see, that's a lot of opportunities for mistakes. The easier thing to do is to recognize that your A value out here in the front is a 1. And if your A value is 1, you could use a pattern 1, 1, 2, 4, 3, 9. So let's go to the vertex and use the pattern 1 over, 1 up, and let's put a dot right there. Let's go back to the vertex, go 2 over, 1, 2, 4 up, 1, 2, 3, 4, put a dot right there. And go back to the vertex and go 3 over, 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. I think that's right. Anyhow, let's map them over to the other side, and we will have our finished parabola right there, and up here. So this is our parabola. It's a nice, beautiful, perfect U-shaped curve. It's not too wide, it's not too narrow. That's because the A value is 1, right? When your A value changes, that's when it gets wider if it's closer to 0, narrower if it's further away from 0 or further away from 1. So anyway, we have our parabola. What else could we say? We've stated the vertex, we stated the axis of symmetry. We could say that this vertex right here is a minimum value, okay? What else? We could state the domain. The domain is x equals all real numbers. The range is y is, where is this parabola at in terms of y? Does it exist at -7? No, it doesn't. At -6? No, it doesn't. It exists at -5 on the y. Okay, so here's the -5 on the y-axis. There's -5. It starts existing at -5, and where's the parabola at? It exists above, at -5 and above. So how do we say that in terms of an inequality that it exists at -5 and above? We say the y values are greater than or equal to -5, which technically this range right here, it comes from the y value of your vertex, right? Knowing that it opens up, knowing that the vertex is the minimum, it does exist at that minimum value of y at -5 and above, so y is greater than or equal to -5. Another thing I could ask you is, what is the y-intercept? Of course, when you want to do that math, you set x equal to 0 and you solve. So if you were to set x equal to 0, 0 take away 2 is -2. -2 squared is +4. +4 minus 5 is -1. So the y-intercept is at -1. Again, if you set x equal to 0 and solve the way I just did, you get your y value of -1. So your y-intercept is at 0, -1. Now, we didn't have to do that math. Why not? Because we already graphed it, and you could just see that it crosses right there. It crosses right here at that location of 0, -1. So we've stated the vertex, we stated the axis of symmetry equation, we knew the pattern 1, 1, 2, 4, 3, 9, we stated the domain, the range, we stated the y-intercept. All of these details could be asked on any, or will be asked on future quizzes and tests. Let's move on to the next even question here. What is the vertex right there on number 4? You guys are correct. The vertex, think opposite on H, take K for what it is, right? So the vertex will be +4 and -6. If you go to +4, let me just write it in, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, you'll be right there. And let's draw our axis of symmetry right through that vertex. And again, the axis of symmetry. So the first thing to do is always find your vertex. There's your answer. Second thing to do is to find your axis of symmetry equation. And that's always going to be x equals the x value of your vertex, which happens to be 4. Okay? So that's another question I could ask you. And now we need more points to be able to graph this parabola. And if we look at the a value out here, it is not 1. Okay? So let's keep this in mind. The pattern that we usually use, is for when a equals 1, and that pattern is 1, 1, 2, 4, 3, 9. And it's important to remember that this pattern came from the original parent graph, y equals x squared. And these are technically inputs and outputs of that original parent graph that had the a value of 1. But as we see up here, the a value is 2. So what we need to do is modify these outputs. We need to modify these outputs by multiplying them by 2, multiplying them by 2, multiplying them by 2, giving us 1 times 2 is 2, right? 1 times 2 is 2, 4 times 2 is 8, and 9 times 2 is 18. So now we have a new pattern, and that new pattern, let me highlight it here, is 1, 2, and then 2, 8, and then 3, 18. And this pattern is from the vertex, and since the a value is positive, it will be opening up. So let's do that pattern. 1 over 2 up. 1 over 2 up would be right there. And it doesn't matter if you go to the left or to the right. You're going to map it over to the other side of the axis of symmetry anyway. So I'm going to the right, and then I'll map it over to the left. The next one is 2, 8. So back to the vertex. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Put a dot right there. And last but not least, 3, 18. 18 is going to be off this graph. 1, 2, 3, 18 is going to be off the graph, so I'm not even going to worry about it. I'm just going to map it over to the other side, put a dot right there, and voila, we are done. This parabola is finished. Now, I think you guys could tell that it's a little bit narrower. It's a little bit narrower than your regular parabola. Why is that? Because the a value is not 1 anymore. It became 2. This a value became 2, which caused a vertical stretch. It got narrower. The a value, as it gets further away from 0, it'll get narrower and narrower and narrower. As it gets closer to 0, it'll get wider and wider and wider. That's not that important right now, but it will be important once we talk transformations. So keep that in mind. The a value does determine whether it's wider or narrower. Let's move on to the last question right here. Go ahead and type in the vertex. Thank you again for those that are participating. The vertex is the opposite of what you see here, and you take k for what it is right there. So the vertex is the coordinate -4, comma, +8. So let's go to that vertex. -1, 2, 3, 4, +8, and that's way up here on the edge. And of course, there's an axis of symmetry running right through that vertex value, and the axis of symmetry equation, A of S equation, is x equals the x value of your vertex, which is -4. That could be a question. That will be a question on the test. From there, we need more points, and we need to map them over to the other side of this green dotted line, the axis of symmetry. So again, when we have an a value of 1, we could use, when a equals 1, we could use a pattern 1, 1, 2, 4, 3, 9. But as you can see, this a value is -2. So the negative just means that it's going to be going down instead of up. But I do need to modify the outputs of this original pattern by the new a value of -2, right? The new a value of -2. So that means I need to put a times 2 right there, times 2 right there, times 2 right there. And notice I'm not including the negative sign. If you want to, go ahead and include it. It'll give you the new outputs. You know what? Let me include it this time since I've never done that before on this video. So what will I get as my new outputs? We're going to get 1 times -2 is -2. 4 times -2 is -8. And 9 times -2 is -18. So our new pattern will be, let me do it with the highlighter, 1 over 2 down, okay, and then 2 over 8 down, and 3 over 18 down. Now the reason why I said it doesn't matter if you include that negative, because as long as you remember 1, 2, but remember that it's opening down, you don't need that negative sign right there. But if you want to include it, go ahead. It's actually a little more clear that you're going to go 1 over 2 down with that. So let's do that. Let's go 1 over 2 down, and we'll get that dot right there. Let's go back to the vertex and go 2 over 8 down. So 2 over 8 down, that will be right there on the axis of symmetry. And then go back to the vertex and go 3 over 18 down. So 3 over 18 down, that's 8 plus 8, that's 16. I'll be 2 units off, so I don't have to graph it. But you know what? It's only 2 units off. I'll draw it right there. Okay, let's map them over to the other side. We have a dot right there, a dot right there, and a dot over here 2 units off. So obviously this is a fairly narrow parabola. Now since those dots are off, you could just put some arrows pointing at those dots that are off the graph. So yes, it's a little more narrow because the A value is -2. The negative means it opens down, but the 2 causes a vertical stretch, which makes it narrower, okay? What else could we state? We could state the domain is x equals all real numbers, okay? State the range. The range are your y values that are up here at this y value of 8 and below. So we're going to say y is less than or equal to 8. We could state the y-intercept. How do you find the y-intercept? You set x equal to 0 and solve. So if you were to put a 0 right here, and notice right here you actually do have to do it algebraically, because if I ask you where does this parabola cross the y-axis, you're like, it doesn't cross. Yes, it does. It will cross, but it's going to cross way, way down here somewhere, way off this graph, maybe even off the paper, right? So what we need to do is solve this algebraically. Set the x equal to 0 and solve. Here's x. Put a 0 right there. 0 plus 4 is 4. 4 squared is 16. 16 times -2 is -32. And then -32 plus 8 is -24, I think. So it would cross setting x equal to 0 and -24 on the y. So the y-intercept will be at the location 0, -24. Obviously that's way off the graph. 0, -24 is way off the graph. It will cross way at that location 0, -24. And that's about it, guys. I've already made a previous video explaining the odd ones. So there are no excuses. You guys should be able to complete this whole worksheet. Wow, wait a minute. I just realized one thing that I have not been talking about. Yeah, we need to know the vertex. We need to know the axis of symmetry equation. We need to know what pattern we're using or what modified pattern we're using. We need to know the domain, x equals all real numbers, the range, y is greater than or equal to or less than or equal to whatever the y value of your vertex is. We know how to find the y-intercept. You set x equal to 0. But the x-intercepts we have not talked about. The x-intercepts, let's just give an approximation of what your x-intercepts are. So when we take a look at this parabola, where does it approximately cross the x-axis? Here's the x-axis. It approximately crosses at, let's say, -0.3 or -0.4. It's not quite -0.5, right? But -0.2. All right. So let's actually go back and state that here. We stated the y-intercept already, but how about x-intercepts? X-ints. What are the x-intercepts? I'm going to say -0.2, 0, and where else does it cross? It crosses, and let me actually do these dots in yellow. It crosses right there, crosses right there. Now obviously this second yellow dot is at 1, 2, 3, 4, and it's a little bit more. So we're going to say at about 4.1, 0. So those are the x-intercept values. I'm giving them as coordinates. Some teachers just say like, where does it cross the x-axis? and you could just say like negative 0.2 and also positive 0.4 or 4.1, right? Let's do these other ones down here as well. Where are the X-intercepts right here? X-intercepts, where are they? They are 1, 2, like about 2.2, 3, 4, 5, and about 5.8, right? So 2.2 and 5.8. Now you could state it like that, or you could write them as coordinates, 2.2, comma 0 and 5.8, comma 0, okay? One other thing is these are approximations, so it probably should be important that we remember to put the squiggly equal sign. That doesn't mean that it's exactly 2.2 or exactly 5.8. These are just approximate values, okay? Let's move on to these right here. Right here, the X-intercepts. What are the X-intercepts? Well, let's count -1, -2. Wow, that's actually a nice X-intercept value at -2. And also at -3, 4, 5, 6. So it crosses, I shouldn't put a comma right there, you guys might think it's a coordinate. It crosses the x-axis at -2 and -6. Of course, as coordinates, you put -2, comma 0, and also the coordinate -6, comma 0. Okay, so those are the x-intercepts. Wow, on this one we did not state the y-intercept, and it looks like a great question. State the y-intercept, especially because you cannot see where this parabola crosses the y-axis. We know that it continues down and forever, which means it's going to ultimately cross somewhere down here. It's going to cross the y-axis, somewhere down here. I don't know what that value is, so obviously visually I cannot state what the y-intercept is, and what I have to do is state the y-intercept according to algebra. So y-int, how do we find the y-intercept? You set x equal to 0 and solve. So for your y-intercept, that'll be the coordinate. The x value will be 0. What is the y value? Let's do that. Let's plug in 0 in for x and solve this algebraically. 0 plus 4 is 4. 4 squared is 16. 16 times -2 is -32, and -32 plus 8 is -24. So the y-intercept will be at 0, -24. Think about that, guys. 0 on the x, -24 on the y. It's going to be way down here where it crosses 0, -24. Anyways, I have given all the information I can on these even questions, and like I said, the odd ones are already posted. I hope we understand this and we'll be ready for this on Friday's test.